So all the information here about the components you can also find in the Eclipse wiki. So since BaSyx is an Eclipse project, a lot of the repository and implementation is supported by the Eclipse Foundation. So they also provide a wiki instance where you can find all kinds of information about the BaSyx and its components. So basically everything I'll say here in the quick start guide, you can also find information here in this Eclipse wiki. It's I would say the first point of information if you are looking for something with BaSyx. The off-the-shelf components here also have an HTTP REST API, and you can find a description of this API in Swagger Hub. So this is basically the latest implementation of this interface. There is an implementation in the C# SDK for a draft version of the next API, but it's basically in development and in progress. And I would say the information you can find here is the most recent one currently. The off-the-shelf components in the Java SDK are implemented in the, or you can find them in the BaSyx components repository. So if we just have a short look at this repository, here you can see the GitHub organization Eclipse BaSyx with all the repositories that contain basically BaSyx, or at least the software part. And here you can find all the SDKs like .NET SDK, Python SDK, Java SDK, and for the Java SDK or the Java implementation, you can find the BaSyx Java components. And here, this is the repository that contains these off-the-shelf components for BaSyx. But for this chapter, I promised that you wouldn't need to implement something or program something. So all the components that you can find here are also provided off the shelf as Docker images. So for the ones that don't know Docker yet, this is basically a virtualization or platform where you can find software that you can run independent of your, or mostly independent of the system environment. So with Docker, you can have, or you can download software or programs as Docker images, which is basically a program that you can just download. And if you run these images, you basically run a container of that program in a virtual environment. So these images are also hosted on a website that's called Docker Hub. And if you have a look here in the Docker Hub for the Eclipse BaSyx organization, here you can find the off-the-shelf components we are talking about in the quick start guide. So here, for example, this is the off-the-shelf component for hosting asset administration shells, the AAS server. And the nice part here is that without building something by yourself or installing some other software, you can just, if you have Docker installed on your system, you can just type in one command like docker pull and then the off-the-shelf component here, the RS registry or server or user interface. Then it downloads the off-the-shelf component and you can basically just run it on your computer. So I will just show how this works, and we'll do that in this quick start guide. So how does it look like? You after installing Docker, you can, and pulling the component which downloads all the necessary files and the image, you can basically start a registry or an asset administration shell server with one command. Let's go into the folder here. Command from here. So, and now moment. Now basically all you do is run Docker run and then include the image name. This will then run the off-the-shelf component in the Docker environment, and then you can also specify a name and a port mapping. So basically tell them how you can access this component from your machine. And then it starts the off-the-shelf component with some default configuration. And yeah, you have run an asset administration shell server. So here I have a software called Postman that I can use to manually trigger the endpoints and the interface of the asset administration shell server. So basically it's an HTTP REST API. So I can just type in or query the asset administration shells that are hosted on the server. And if I do this, I of course get an empty answer, more or less, because I just started the server and didn't upload any asset administration shells yet. So we will also do this within the next steps. Yeah, but just as a reminder here, so this triggers the HTTP REST API. So basically it doesn't matter if you do it in Postman or like the browser. So I could also open a browser here and type it here, as long as I do this query, and then I get the same answer. So basically an empty list, because there are no shells in this asset administration shell server. Now the same goes for the registry. So if I just stop this here in the background, I can I now started the AES server, but registry, and I can start the registry to yeah, start the off-the-shelf component of the registry and then get all the registered asset administration shells in the system. So also an empty list, of course. Now let's try to do a little bit more. First of all, the registry itself is, as I already said before, is used as a registration or a central entity where you can register your asset administration shells in the system. So you can basically register them with AES descriptors, and here you can find the endpoints of the asset administration shell. So you could have multiple asset administration shell servers in your system, each with another endpoint, and each maybe also with multiple asset administration shells, and then you can register them all on your registry. and find or an application can then find the endpoint of that asset administration shell descriptor. So if the application knows the ID of an asset it looks for, then it can use the registry to get the asset administration shell server that hosts the digital twin of that asset. Note, however, here that the registry is no discovery in the sense of that it you can really use it to browse your system. So this would be another component. In BaSyx, we have an implementation of a tagged registry where you can kind of group your asset administration shells, for example, with tags like device, product, and so on. But still, if you would don't know the ID of your asset administration shell and are looking for some criteria, then you would need another component that also does this and provides the capability to search for specific asset administration shells. Yeah, we already did that. So let's look into the configuration of these of the shelf component, because the off-the-shelf components implement several features that you can turn on and off as you need it. So let's start with uploading an asset administration shell to your asset administration shell server and see how that works. So within this folder here, I have several configuration files. So first of all, most importantly, I created an ASX file. So the ASX file is basically the contains the static structure of your asset administration shell that I want to host on my server. So there's a tool called ASX Package Explorer that you can use to open these ASX file and have a graphical user interface where you can look at it and also create some ASX file by your own. And here for this quick start guide, I prepared a small asset administration shell that basically contains two very simple submodels, like a sensor and a control submodel. A sensor submodel contains some data, current temperature, and in the control submodel there's an operation set temperature. And in this example here, I first want to just load it on the asset administration shell server. So how do I do this? For the off-the-shelf component of the asset administration shell server, I have some property files where I can configure the features. And the main one for the asset administration shell server is this AAS.properties. And if you look at it, here you can enable or disable and configure the properties of that AAS server. So for example, if you wanted to upload an ASX file when the AAS server starts, then you can use this property AAS.source and define the location where that ASX file is hosted. Let's turn paths here off for now. So here in AS source, I specify the path in the Docker within this Docker container where the ASX file will be. So here, for the sake of this demonstration, I'll put it into that container into user share config open ASX, and then when I start that off-the-shelf component, I will have to specify this configuration. So this is basically the same command that I used before, but the only addition is this one. So I specify that in user share config, where this AES properties should be within this container, there I want all these files to be copied, or mounted. So this is basically this folder here with the ASX file and all the property files. So if I just run this command, then the same component starts, but now it will upload the ASX file. And then if I use Postman to query the SH administration shell server, so now I ask for the shells that are in there, then of course I get an answer, and now I get the asset administration shell data basically. So here this shells asks for all the asset administration shells and just gives me now this one that I uploaded during start. And now I can also use the API and the endpoints to look into that asset administration shell and, for example, ask for the submodels that are in there. So this I'll do with that command here. So I ask for shells, then the ID of that asset administration shell, and then /AES submodels. And now I get my two submodels, control and sensor. So basically these two, sensor and control. And here I can then also ask, for example, for all the properties within that sensor submodel in this example. So /submodel sensor and then all the submodel elements in there. And then I get my one property, the current temperature. And if I then also ask for its current temperature value, I get the value of that specific property. Since I didn't set the value yet, this will be empty here, but I could set it here in the ASX file and then get the value of that property. And in this regard, an application could also be implemented to query all the other properties here, or also run an operation and so on. All right, then let's look at one or two other features here. Basically, what you can, we looked at that file here. Basically, what you can also do, so if you would like to specify your network configuration in another way, you could also use this context properties here to define the port or the path in which you can access the server. So you could change basically this prefix here and set it on another port within the Docker environment, and then yeah, use that configuration here to change that. Then the AES property also has a few other features. So here, if we open that, yes, I'd like to reload that. We can specify a backend for the asset administration shell server. So additionally to what we did now in memory, we could also use a database to backup and persist the data in the asset administration shell, so that if you use the off-the-shelf component really to upload asset administration shells and change some values within your runtime, you could use MongoDB in BaSyx to persist the changes, and then when the off-the-shelf component starts again, then it will load all the data from the MongoDB and start with that state there, so that you don't lose all your changes when you restart your off-the-shelf component. Then another property here, or another extension or feature that we implemented in the Java SDK is eventing. So we use MQTT events, or can use MQTT events to get or propagate specific events within the registry or the asset administration shell, so that you can, for example, trigger an event when we're just doing new asset administration shells, or you could trigger an event when setting values in a property, and then an application could get notified with these events to be able to listen to changes in your system via the registry, for example, or the asset administration shell, and then react accordingly. So I'll show you that with the registry in a moment. Then we have a feature for ASX upload. So this is already enabled. So if I don't have this asset administration shell in the beginning, let's restart that and start the server again. This new configuration. So since I did not persist my changes, the server is since I did not persist my changes, the server is still empty. And now I can basically upload asset administration shells using these ASX files during runtime. So with Postman, for example, it's quite easy. You post to the /ASX endpoint and then add the ASX file to your post command as a form data. And then if I send this will upload the ASX file during runtime. And then if I ask again, it's uploaded. So you can also use this to upload ASX files or multiple ASX files after the server has been started. Then let's also take a look at events. But for this, we would like to combine registry and the AS server and start them both, and also register the AS that we upload. So what you can do with Docker is that you put your registry and your asset administration server into the same network, and then also run them separately. But we'll do this not manually one by one, but we'll now create or define our environment with a so-called Docker compose file, and then run them with one command. That we talked about, and the MQTT. I'll show that in a moment. But first, let's look at that Docker Compose. So here in this folder, I have my definition of the environment I want to start. So if I look at that, this is basically the Docker Compose file. And here we define our images or containers that should be run and the configuration. So we want to start the registry and the asset administration shell with the configuration that is here in this folder. So instead of running them individually, I can just define all the configuration, start configuration in the Docker Compose, and then just say Docker Compose up and start them. Yeah, I just, because the AES has been created before, it can't do that again here, but I can remove them and then do that again. And now I have the AES server and the registry together in one network. And here in the configuration, I now also say that my ASX file should be loaded on startup. And I specify in the AES properties that I also want to register the asset administration shell that is uploaded during startup. So I set the registry path to this path. So this is the endpoint of the registry. It's registry, since this is the name of the container here, registry. And yeah, then if I start that again, the registry and AES server start, and the ASX file is uploaded to the AES server, and the server will automatically register the asset administration shell. So if I now query the registry for all the asset administration shells that are in my system, I get as a response the descriptor of that asset administration shell. And in the descriptor, you have some meta information like the identification or name of the asset administration shell, and also, most importantly, the endpoint of that asset administration shell. So here I get, it's that one. I get the asset administration shell. So this does not work since the port here is relative to the Docker containers, but I could also use the registry host path to define my local host. So here I could say that the containers should always be registered to the port that I see from my local host. So basically that one. And then the information in the registry would also be correct for my local deployment here. All right. Then let's have a look at a little bit more complex example. We now had only our registry and AES server and looked at the configurations. So for the AES server, we have the backend that we can configure asset administration shells uploaded at the beginning, eventing and uploads. Now the next thing I would like to show is when Docker Compose with some more complex deployment, and therefore in BaSyx we have an example already set up that shows exactly this. So if you look at the BaSyx examples repository in the GitHub, then you can find all kinds of examples for coding. So I will go into detail there a little bit more in the next chapter. But here there's also in the development branch deployment with Docker Compose that defines basically start configuration for the registry, the asset administration shell, and also a graphical user interface. So this is the third component I'd also like to show. So here we basically have the same that we now did here. So two components with our port mapping, our configuration, and registry and AS server. So that you can also find in this example, the registry AS server with a port mapping, and then instead of mounting our property files into that Docker container, like we did here and here, there's an alternative way of configuring the Docker components, and that is this environment specification here. So you can use all the configuration I showed here in the property files as environment variables. So if you use a prefix for the property files and change the naming scheme so that you replace dots with underscores and write everything small, then you can basically specify, for example, here this backend in the start configuration here in the Docker Compose. So that you don't have to mount some configuration files into your container and directly specify your configuration via system environment variables. So here for the AS.properties, the prefix for that property files would be BaSyx AS, and then we have AS backend, basically that, and in this case in memory, and it's the same for all the other configurations here. So there's a BaSyx context for port and path. Then there's the registry path where the asset administration shell should register the asset administration shell, and also because we now have a web user interface that directly accesses these containers in the browser. There's also another setting for allowing this cross-origin origin access. So that's basically this last configuration here. And in the waiting for, it's also another addition where the asset administration shell waits for the registry actively to then upload the ASX file after the registry has been started. So it's basically a safety line that it can't, so that it can't happen that the ASX file is up before the registry. And the last container here is basically just the off-the-shelf component, the AS graphical user interface. And that one will I will show here. So what did I do? I basically copied the BaSyx examples also on my local folder. So if we can execute it directly here on the machine. So this is the BaSyx examples repository, and here in the BaSyx Docker and simple deployment with graphical user interface, that's the Docker Compose file that we can also see here on the website for this GitHub repository. So same procedure. I type in one command, compose up, to load that whole environment here, and it will once again it will start the asset administration shell of the shelf component, the registry of the shelf component, and the graphical user interface. And now in the Docker container of the user interface, it needs a moment to start up. The registry and the asset administration shell is already up. So I can already get them with Postman here if I query them manually. So we have in the registry, we have 2 asset administration shells in the system that are registered. And now it's up. Oh no, not yet. Yeah. Now it's up. So I can go to the endpoint of that UI, and now in the registry server URL, you have to type in, or basically in this example it's already there, but you can type in the endpoint of your registry because there all your asset administration shells are registered, and then you can connect to that registry, and then on the left it will show all the asset administration shells that are in your system, and then you have a quite easy way to navigate through your asset administration shells, and also within the asset administration shells all the submodels. So for example here an identification submodel that contains information about or general information about the asset, for example manufacturer and so on, and I can just query all the properties and data within that asset administration shell. So that one a little bit simpler. All right. So we have that. And now you have a sense of, or you know the off-the-shelf components for asset administration shells, servers, the registry, and the graphical user interface, and basically how to configure it. At the end of that chapter, I'd also like to talk a little bit about the context here and make an overview also. And then we can also try out the MQTT feature. so that you can see how that works, and take a little bit more detailed look into that. But basically, if you have an environment that uses all the off-the-shelf components, then it basically looks like that. That you have from the Docker Hub website, from the image or the container registry, the images are loaded. So you can download all the images here and start all the Docker containers in your Docker virtual machine. So here in the last example, we started the registry, the off-the-shelf asset administration shell server, and the graphical user interface. And then you have the option to also persist the changes in the registry and the AAS server via MongoDB. And now in a later chapter, I will also show a little bit more about how to use another component that is in development to also update data in the off-the-shelf AES server. Because what we did now is just uploading static data into the server. So if you had an external system, so for example, a device, like the temperature sensor that is like teased in the submodel that I showed, then you would also need a way to get your data into the off-the-shelf component or into the asset administration shell. So the ASX file itself is static and doesn't do anything by itself. So if you wanted to connect a device with the asset administration shell, you would also need another component. I call it here the data source specific gateway that basically updates the properties in your system and knows how to get the data from the data source. So this is for a device very specific to that device, or in general for the data source specific to that data source. So if you want to load data from a I don't know, an SQL database to the asset administration shell, you would of course need a connector that queries the database and then pushes the data into the asset administration shell. Or if you have a device with, for example, an OPC UA interface, then you would need an implementation that knows this OPC UA's interface and knows how to get the data from that device to be then able to push the data into the asset administration shell. So that's basically the possibility with the off-the-shelf component in Java for connecting to a data source. In the next chapter, we'll also see another possibility for programming this connection, but for the off-the-shelf component here, you would use the HTTP REST API to push data into the AES server. Yeah, and then we in the second example we did it via environment variables, but you could, as we did before, also mount the configuration files into the container and use also the Docker Compose to define your start environment, or optionally also use ASX files to get the static structure into the off-the-shelf component and the AES server. So last but not least, we'll also use I'll also show the MQTT capability. So let's to the AES server, exit that, and then I'll start I'll open the configuration. So what I'd like to do now is that in the registry of the shelf component, I enable the MQTT feature. So that every time an asset administration shell is registered in the registry, an event is fired and could be catched by some other application. So that other application could subscribe to the event to get notified when new asset administration shells are uploaded into the system. And for this, we turn that feature on in the registry properties, and then also use the MQTT property to specify our MQTT broker. So for MQTT, it works in a way that we have an MQTT broker that runs next to the registry, and then the registry will push events or notify the broker when the event has been fired, and other clients can subscribe to that broker to get notified if any kind of event is fired there. So in the MQTT properties, I'll define the server endpoint for my broker. So I started a broker on my local machine. So I use that endpoint basically to get to that which is the broker endpoint from the perspective of that registry running in my Docker environment. And for my configuration here, that's basically it. So I just start an MQTT Explorer where I can let's clear that, where I can connect to that broker. So also that same port, connect to it, and then now I listen to the events that are fired and are sent to that MQTT broker. So you could also have another application that does exactly that, which subscribe at the broker and then listen to the register events for the registry. So let's get back to our example. Here we go. Quick start guide and AS server, and then in the Docker compose, that's the location where I configured that property file. And now in the AS server, I checked that the asset administration shell will be loaded on startup and then registered at the registry. So what we should see is that when I start this, the AS server uploads or the ASX file is uploaded to the AS server. The AS server registers the AS at the registry, and then the registry should fire an MQTT event here. Let's try that. And here you go. All right. Possibly I used a wrong configuration path here. Let's just double check. Yeah, if it does not work on the fly, then we'll also in the registry the AES hasn't been registered. And in the AES server, we don't have the asset administration shell, so the server isn't up. Let's try again. Possibly the components started in the could be that the AES server started before the registry and then it didn't find the registry. That's also the reason why in the other example there's this waiting for, so that the AES server waits for the registry to be up. Yeah. So that's basically the main reason why this waiting for is in the other example, because then the AES server waits for the registry and then registers it. Here in the previous try, the AES server was up and then we just tried to register its asset administration shell, but the registry wasn't up yet, so it couldn't. In the next try, it worked and the registry fired also that event with the BaSyx registry registered AES topic and the identifier of that asset administration shell that has been uploaded to the AES server. Okay, I can also upload then another asset administration shell manually by just manually triggering the endpoint on the asset administration shell registry, and I'll put a new descriptor to that registry, and then I'll get another event that a new asset administration shell has been registered there. Okay, that's how the MQTT feature works. In the same way, you could also configure other features of the BaSyx, and likewise to the MQTT feature and the other features, you can find all the configurations I showed here also in this Eclipse wiki.